Alright, Physics 2212 Lab 2, Sophion Manga. Let's get into this. So for the introduction, the purpose of this lab was to recreate two charged tapes interacting with one another. Similar to the previous lab, however, this time we modeled the tapes as line charges, and then we compared the difference in the charge values. And here you can see an overview of both labs. The lab 1, when we did it as point charge, the charge we got for a tape was 4.61 times times 10 to the negative 9. And the line charge, this lab was 1.55 times 10 to the negative 8. Concepts and assumptions we used for the equations, we used force of gravity, electric field, and force of the electric field. You can see those three right here. Principles, Coulomb's law, Newton's second law, and superposition, which is like, E net is equal to the sum of all the different electric fields present. System was the tape, surroundings was everything else, and for assumptions, we assumed that the charge is equally distributed. We did not account for air resistance or any other type of friction, and we assumed that both tapes have equal amount of charge. And here you can see a couple of figures. Figure 2 is how we actually created the charged tapes, and figure 4 is how we set up our experiment to make the tape float. Alright, moving onward to our glow script. So here I will show you overview of lab 1. You can see the charge of the tape that we calculated right here, 4.61831 times 10 to the negative 9, and gravity and electric are equal to each other, and then a bunch of other calculations that we had for lab 1. Moving on to lab 2 code, I added the separation distance, the distance between the two tapes that I calculated when I did the experiment in not in glow script, and then the mass of the tape that we calculated. And here is our lab 1 charge for a tape, but I multiplied it by a constant so that way that electric field and gravity force would be equal and opposite, and we'll print that out and you'll see that at the end. Here we have a function to calculate the electric field. Moving onward, we model our two tapes. I had a step of 50, so there's 50 spheres or 50 points for each tape. You'll see that in the model at the end. And moving onward, we have a couple of for loops to calculate our force of electric field on the top tape due to the bottom tape. And then right here we are going to print out the arrows, or draw the arrows of the gravity and electric force, and see that right here. So there's my 50 steps or points or whatever, two tapes, and green arrows are the electric field on each bit of the top tape from all the bottom bits, and white is the electric field, and yellow is the gravity force. Sorry, white is electric field force. And you can see right here the charge of one tape is 1.54746 times 10 to the negative 8, which is very different from our lab, where am I? Lab 1, sorry. Moving onward, for comparison, as you can see, the lab 1 point charge was that, I don't feel like saying it again. Lab 2, we were using a line charge. We calculated the charge on the tape to be that. And some similarity between the two labs is that force of gravity and electric field are still equal and opposite, and the calculation methods is the same. We use the same concepts and assumptions in both labs. However, lab 2 was a line charge model and lab 1 was a point charge model, as you saw in the glow script results. Moving on to our sources of error, most of them stem from our assumptions. The assumptions being that charge is being equally distributed on the tape surface, not accounting for air resistance, and assuming that both tapes have an equal amount of charge. Some more sources of errors are from our handling of the tape, and when we were actually doing the experiment. In figure 2, as you saw, when you rip the tape off of the other one to charge it up, when you're handling it, it could lose some of the charge, it could dissipate the charge and whatnot. And furthermore, when I was doing that experiment as well, the separation distance could have been calculated a bit more precisely. I just used a ruler and my eyeball, but I think I got pretty close. What if and why? What if we had modeled each tape as a single point charge, like in lab 1? And you can see we've been comparing that all throughout these slides. Lab 2's tape charge was over 3 times bigger than lab 1's tape charge. And why do these estimates differ? And which one is more likely to be closer to the real value? In lab 2, we use a line charge model, which is why it differs so much. And lab 2's charge value is going to be more accurate as it more realistically models a tape. For our conclusion, you can see that a line charge yields a more accurate result for the tape charge, A point charge offers fast calculations due to the many simplifications, but it does trade off the accuracy. It gives you like a idea, general direction to go into, but if you want to be more accurate, you have to put in more work. Alright, that'll be it. Thank you so much.